Let's get started on Module 5, Virtual Networks and Virtual Switches. In this section, we will discuss virtual switches, and we will discuss configuring virtual switch policies, and then we will do an introduction to distributed virtual switches. But before we talk about a virtual network infrastructure, let's do a review of a physical network infrastructure. A physical switch, as you know, connects servers to servers and connects users' workstations to servers and connects everyone to the router, which is the internet connection. There are 4 types of networks associated with an ESXi host. Production network, which carries user traffic, the storage area network, the management network, and the vMotion network. Let's look at each one of those 4 types of networks. Now, the first one, the production network, most people are already familiar with. The production network is where the user's workstations connect to the switch, which connects to a physical network interface card in the ESXi host. And the purpose of the production network is to carry user traffic from the user's workstations to the virtual machines which are on the ESXi host. Most people are already comfortable with the production network. Now, another type of network is the SAN, the storage area network. The storage area network connects disk arrays by way of a switch to a physical network interface card in the ESXi host. And the purpose of the storage area network is to carry traffic from virtual machines in the ESXi host to the disk arrays. The purpose of the management network is to connect the manager's workstation. That's your workstation or my workstation. The network administrator's workstation connects by way of the management network. And you say, a whole network segment just for me? Why would we have that? Well, if the production network is totally congested and the storage area network is totally congested, the management network still allows us to get to the ESXi host and to configure it. The purpose of the management network is to let us, as network administrators, to let us configure the ESXi hosts. A 4th type of network is the vMotion network, and what the vMotion network does is it carries traffic between ESXi hosts. And we will discuss vMotion later on in the course. 4 different types of networks, and there are essentially 2 different configuration options. You could have a separate physical network for each type of network traffic, or you could have all of the different types of network traffic on one physical network. Now, ideally, you have a separate network for each type of traffic. The production network is a separate network, the storage area network is a separate network, as is the management network and the vMotion network. But that can be kind of expensive. Another way to go is to have all network traffic on one single physical network, production, storage, management, and vMotion. But the problem with that is all of that traffic on one network tends to lead to congestion, which slows everybody down. The ideal network configuration is where you do have a separate physical network for each type of network traffic. But most commonly, most organizations combine the 2. A typical network configuration has 2 types of network per physical network. So here is an example that you see in many institutions. We see the production network and the management network on the same physical network. And that kind of makes sense, because imagine you or me, the network administrator, we're standing at our workstation, and the workstation connects to the production network, and that switch connects us to the ESXi host, and we can manage it that way. And then A separate physical network might be used for the storage area network and for vMotion traffic. Review. A switch connects servers to servers and users' workstations to servers. And there are 4 types of networks associated with an ESXi host. Production, which carries user traffic, storage area network, network management traffic, and vMotion traffic. And they can each have its own physical network, or they can all be on the same physical network. This is true for the physical network infrastructure, and it's also true for the virtual network infrastructure. So now that we've done that little bit of background, now let's turn to our introduction to standard virtual switches. Just as a physical switch connects servers to servers and workstations to servers and everybody to the router, a virtual switch connects virtual machines to virtual machines and connects virtual machines to the physical network interface card, which connects to the physical switch, which connects to the user's workstations, and which connects to the router. And you can see in this diagram, virtual machine 2 is connected to virtual machine 3 by way of a virtual switch. Virtual machine 1 connects to the virtual switch, which connects to the physical network interface card, which connects to the physical switch, which connects to the user's workstations and the router. Let's look at an example of a virtual switch on an ESXi host. This is an ESXi host, and this box is a diagram of the ESXi host. And virtual machines run in the ESXi host. An ESXi host will have at least one network interface card. That physical network interface card connects to the physical switch, which connects to the user's workstations, and which connects to the internet connection. So the question is, how do all of these virtual machines connect to one physical network interface card? And the answer is a virtual switch. A virtual switch is a piece of software that emulates a physical switch, and the purpose of the virtual switch is to connect virtual machines to virtual machines and connect virtual machines to the physical network interface card, which connects to the physical switch. Here is another diagram that shows the same thing. The virtual switch connects virtual machines to virtual machines and allows virtual machines to connect to the physical network interface card, which connects to the physical switch. Let's examine the default virtual switch, and we will use the vSphere desktop client to connect directly to an ESXi host. Now, we're not going to use the vSphere web client, and the reason for that is because the web client cannot connect directly to an ESXi host. The vSphere web client can only connect to the vCenter server, which can be used to manage ESXi hosts. So we will use the desktop client to connect directly to the ESXi host. You can see we've got the vSphere desktop client and we're connected to an ESXi host. If we select the configuration tab and then under hardware we select networking, we can see that this vertical bar represents the switch. It looks like a switch turned up on its end. This is the virtual switch. Notice the virtual switch 0, is connected to a physical network interface card, which is connected to a physical switch. Also, a port group is connected to the virtual switch, and a port group is a group of ports, and this one contains 5 virtual machines. So these 5 virtual machines are connected to the virtual switch, which connects to the physical network interface card, which connects to the physical switch. Notice there is another port group here called the management port group, and of course that's what you and I use to manage and access the ESXi host. Let's click on the properties of that virtual switch, and if we look at the virtual switch and click on the edit button, we can see that this virtual switch has 120 virtual ports. And what that means is we could bring up 120 virtual machines and connect them all to this virtual switch. Now we could increase that number if necessary. We also see that the maximum transmission unit size is 1500 bits. If we look under the Network Adapters tab, there is our vMNIC 0, and we click on Edit, and we click on the drop down. We can see that if we want to, we can configure this network interface card to run it at 10 megabits per second, and we might do that for backward compatibility with an old operating system, but usually we leave it configured for auto negotiate. VLANs, Virtual Local Area Networks. ESXi supports 802.1q VLAN tagging. ESXi provides VLAN support by allowing us to assign a VLAN ID to a port group. But let's do a brief review of VLANs. If you had a single segment and you wanted to divide that single segment network into two separate networks so you could separate your computers, then what you could do is you could buy a second switch. You could buy a second switch and put half of the computers on one switch and half of the computers on the other switch. And what that would do, it would create separate segments to separate the computers. And the reason we would want to do that would be to limit broadcast traffic, to reduce network congestion, and for purposes of security. But the problem is, if we only have one switch and we don't have the funds to purchase a second switch, how can we separate the computers into separate local area networks? And the answer is VLAN, Virtual Local Area Network. A VLAN is where we take a single switch and we logically divide it into two separate logical subnets, which we will call VLAN 1 and VLAN 2. And these computers are isolated from each other. It would be just as if we had purchased a second switch and moved half the machines to the second switch. But with a VLAN, we can logically divide our network into separate logical segments as if we had broken our network into two physical segments. That's what a VLAN does. So to configure the VLAN, ESXi provides VLAN support by allowing us to assign a VLAN ID to a port group. And as you know, a port group contains a group of virtual machines. So to assign a VLAN ID to a port group, we go to the configuration tab of the ESXi host, and under hardware we select networking, and under networking, under vSwitch 0, we select properties. And now I can see there are several different port groups there. I will go to the first port group and click on edit, and I will assign a VLAN ID of 1. And then I will go to the second port group and click on edit, and I will assign it a VLAN ID of 2, and I will do the same for the remaining port groups. And what that will do is it will separate and segregate those virtual machines from each other. A VLAN allows us to logically separate groups of virtual machine. And it allows us to create VLANs by assigning VLAN IDs to port groups. Now, let's turn our attention to virtual switch policies. There are 3 different virtual switch policies that we will discuss: security policies, traffic shaping policies, and network interface card teaming policies. And these policies can be configured per virtual switch or per port group. To configure those policies, we will go to the Configuration tab of the ESXi host and to Networking, and you can see here is our virtual switch. If I click on Properties followed by Edit, you can see there's the Security tab, the Traffic Shaping tab, and the Network Interface Card Teaming tab. Let's click on the Security tab. We have an item here called Promiscuous Mode, and when you enable Promiscuous Mode, it allows that virtual machine to hear all traffic which is being sent to and from all other virtual machines on that virtual switch. For the average virtual machine, you would not enable Promiscuous Mode. However, if you had a protocol analyzer on the virtual machine, you would want to enable Promiscuous Mode. A protocol analyzer is a program that listens to all traffic on the network. Good guys use protocol analyzers to solve network problems, and bad guys use protocol analyzers to steal credit card numbers and passwords. So what we can do is, if we do want a virtual machine to hear all the traffic on the network, under Promiscuous Mode we would select Accept. MAC address changes and forward MAC transmits. Typically, a virtual machine or an operating system is not going to change a MAC address. This typically only happens in specific applications, particularly Microsoft Failover Server. So if you're installing an application such as Microsoft Failover Server, which does do MAC address changes, then you would change this to Accept. But typically you would not. And then the next tab I would like to discuss is Traffic Shaping. And traffic shaping is also called bandwidth throttling, and you would do it under the circumstance whereby a couple of virtual machines are gobbling up all of the network bandwidth and not leaving any for anyone else. So what we can do is this. If we see that network utilization is excessively high, and if we see that certain virtual machines are gobbling up all of that network utilization, well, what we can do is implement a traffic shaping policy. Network traffic shaping is a mechanism for controlling bandwidth, and it's also called bandwidth throttling. With traffic shaping, we can configure the average bandwidth and the peak bandwidth and the burst size. What we can do to enable traffic shaping is to select the drop-down and to select Enable. And then under average bandwidth, you can see that's set to 100 megabits per second. And the reason we limit it is so this virtual machine does not take up everybody else's bandwidth. But there are times when this virtual machine will need the full bandwidth. So we set the peak bandwidth to 1 gigabit per second, the entire bandwidth. So the virtual machine will have the entire bandwidth, but notice the burst size is set, so the virtual machine will only have the peak bandwidth for a set period of time. So what we've done is we've configured this port group, or this virtual switch, such that the average bandwidth is 100 megabits per second. The virtual machines can occasionally get 1 gigabit per second, but only for short periods of time. And then the third variable to configure is network interface card teaming. And network interface card teaming can be implemented when you have 2 or more network interface cards in an ESXi host. Notice we have 2 network interface cards on this virtual switch in this ESXi host. So the question is, why would you have two network interface cards in an ESXi host. And there are three reasons: fault tolerance, load distribution, and the ability to connect different networks. Let's start out with the first example, having two network interface cards in an ESXi host for fault tolerance. The reason you'll have two network interface cards is that one network interface card would do all the work, and the second network interface card would simply be the standby network interface card. If the first network interface card went bad, no problem. The second network interface card would then take up the slack. This is called failover. When one network interface card fails and the other one takes up the slack, this is called failover. Let's look at configuration for failover. If we look at network interface card teaming, we can see it's currently configured to use explicit failover. Look at our network interface cards. One is the active adapter. vMNIC 0 is the active adapter. It does all the work. And vMNIC 1 is the standby adapter, and it doesn't do anything until the active adapter fails. When the active adapter fails, then the standby adapter kicks in. That's called failover. Now, failback is when the first network interface card comes back online, and then the network traffic reverts back to the first network interface card. Notice under failback, failback is enabled. Now, you could set failback to no. Why would you set failback to no? You might do it in the situation whereby the first network interface card is intermittently bad, and what this does is it prevents flip-flopping from one network interface card to the second network interface card. A second reason for having two network interface cards in one ESXi host is for load distribution. What load distribution means is combining two network interface cards, and these two network interface cards work in tandem to provide greater speed. If you only had one network interface card, in this example, you would only have 1 gigabit per second. But by having two network interface cards working together, then that doubles our throughput and gives us 2 gigabits per second. To configure for load balancing, we're not configured for that right now. We're configured for failover. And notice we only have one active adapter, and the second adapter is standby. It's not doing any work at all. So I want both network adapters to do work. So I select the second network interface card, vMNIC 1, and then I select Move Up. Now you can see we have two active adapters, and they will work together to provide load balancing. And if you look under load balancing, you can see there are a couple different load balancing methods, such as route based on the originating virtual port ID. Let's look at those load balancing methods. Now, the load balancing method based upon originating port ID, the purpose of that load balancing method is to provide or distribute an equal number of ports to each network interface card. And this load balancing method uses a round robin load balancing method. So here's what round robin means. What we have is 3 network interface cards. So the first virtual machine will be associated with the first network interface card. The second virtual machine, which is turned on, will be associated with the second network interface card. The third virtual machine, which is turned on, will be associated with the third network interface card, and the fourth virtual machine, which is turned on, will then be associated with the first network interface card. This is what's called a round robin load balancing method. Now, a weakness of this method is that one virtual machine cannot send traffic over 2 network interface cards simultaneously. A second load balancing method is called source MAC hash based load balancing method, and the purpose of this load balancing method, just like the previous one, or very similar to the previous one, is to provide an equal number of MAC addresses which are assigned to each network interface card, and it too uses a round-robin load balancing method. The disadvantage is one virtual machine cannot send traffic over two network interface cards simultaneously. A third load balancing method called IP hash uses the link aggregation control protocol to distribute traffic across multiple network interface cards. And one of the big advantages of it is that it allows one virtual machine to send traffic across two network interface cards simultaneously. Of course, the catch is it requires that your switches support link aggregation control protocol, which is IEEE standard 802.3 AD, and not all switches support that standard. So we typically go for the default, which is root based on the originating virtual port ID. There are three reasons for having two network interface cards in one ESXi host: fault tolerance, load distribution, and the third reason is to connect different switches. In this section, we have to create additional virtual switches. And you might say, well, there is already a default virtual switch. Why would you create an additional virtual switch? And the answer is to connect multiple networks together. So here's the example. We have a single ESXi host which has one physical network interface card, and all of the virtual machines use this one virtual switch to connect to this one physical network interface card, which connects to the physical switch. Now, if we were to add an additional second network and then connect that physical switch by way of a network interface card to the ESXi host, we would now be connected to two separate physical networks. And what I want to do is to have the virtual machines on the right connected to the network on the right, and the virtual machines on the left connect to the network on the left. And the way I would do that would be to create a second virtual switch. I would create a second virtual switch whereby the virtual machines on the left would be connected to this virtual switch, which is connected to this physical network interface card, which is connected to this physical switch. And that these virtual machines on the right are connected to this second virtual switch, which is connected to this second physical network interface card, which is connected to this separate physical network. So we can see that some virtual machines connect to one network and other virtual machines connect to the other. To do that, under Configuration, under Networking, on the top right, we see Add Networking. So we click on Add Networking, and under Connection Types, we select Virtual Machine, because this will handle virtual machine traffic. Then we click on Next. Then we do not select the network interface card which is currently in use, vMNIC0. We select the second physical network interface card, vMNIC1, followed by Next. We give the port group a label, such as Research and Development. We click on Next, and we click on Finish, and now we can see a separate virtual switch has been created, and that connects to the second physical network interface card. Now, if you look in the port group, no virtual machines are currently connected to that virtual switch. So what I want to do is take some of the virtual machines which are on the first virtual switch and move them to the second virtual switch. So database server 2, for example. So what I want to do is I want to move a virtual machine from one virtual switch to another. So here's what I do. I go to the virtual machine I want to move, in this case database server 2, right click and select Edit Settings. And then under Network Adapter, it says it's currently connected to the default VM network. If I select the drop down, I can then connect it to the Research and Development port group, which is connected to the new network interface card, and to the new switch. And then if I go back to the ESXi host, back to the configuration tab, now I can see for this virtual switch we have now added a virtual machine to this virtual switch. You can use virtual switches to connect different virtual machines to different networks. Thus, these virtual machines will be associated with this network, and these virtual machines will be associated with the second network. In summary, there are 3 reasons for having multiple network interface cards in an ESXi host: fault tolerance, load distribution, and the ability to connect to different switches. In the next section, we will discuss distributed virtual switches. And this concludes part